Dr. Scott Pace. Traditionally, NASA's Earth Science Division focused on one-off research satellites to demonstrate technology and science. Recently, however, NASA was given responsibility for the Sustainable Land Imaging Program and a number of NOAA's long-term satellite observational requirements, including TSIS-1, the Ozone Mapping and Profile Suite, OMPS, and the JPSS-2 Radiation Budget Instrument, and future ocean altimetry missions. How, if at all, do these new responsibilities represent unique opportunities for public-private partnerships?
Okay, thank you, Mr. Chairman. Each one of these missions is somewhat different, and as my colleague was saying earlier, needs to pay attention to the particulars of each case. In particular, finding non-government or non-NASA agencies who want the data. In the case of Landsat, at the risk of continuing the Rodney Dangerfield analogy, I think that the technical risks in providing that data tend to be the most well-bounded, and there are multiple non-NASA users, and that given the right incentives, commercial entities could fund development, test, and operation of those systems. However, that option, I think, has been largely precluded by the intent of Congress that NASA would develop the next Landsat satellite pretty much as a repeat of earlier satellites. And I would simply look at the NASA Appropriations Conference report for fiscal year 2015, which really precludes any sort of out-of-the-box approaches to data collection. That's why I talk about the need for some sort of on-ramp or parallel activity, maybe revising the science data buy, or maybe looking at some more partnerships with NGA in each of these areas, and to not prejudge what the outcome would be, but maybe have a competition through NGA or through the SDB and see what you get. I would suspect that the Landsat option would come in pretty attractively, but then there would have to be a robust internal discussion in the Congress as to whether or not they wanted to have that on-ramp, or really whether they wanted to continue with the current appropriations language.
Thank you, Dr. Pace. And this next question is directed to Dr. Scott and Mr. Schingler. According to the 2007 Earth Science Decadal Survey, an emerging source of data is the commercial sector. In the past, a program of Earth observations was associated almost exclusively with government-managed or government-sponsored projects. Today, commercial sources of Earth information are rapidly increasing in availability and scope. Commercial satellite systems are now reliable sources of high-resolution Earth imagery, and commercial remote sensing companies have greatly expanded their offerings. In your opinion, where does the commercial remote sensing sector stand today, and how can the commercial sector fulfill civil government Earth observation needs? Dr. Scott, you first, and then Mr. Schingler.
So I'd say I'll break the answer down into two parts. The first part is to leverage those data sources that already exist, bearing in mind not to break the business model. So we've talked a fair bit about where sharing of data can be bounded by licensing. So, for example, sharing of data to the research community, but perhaps not in a way that undermines the commercial benefit broadly. We have such an agreement in place with NGA, where NGA has quite a degree of ability to share within the government, with coalition partners, with allies, but that does not undermine our ability to serve our other commercial customers with different licensing models. So it's possible for those to coexist. Then I think the second part is to leverage the commercial sector to create data sources that might not yet exist, but which could be created cost effectively, because the commercial sector is able to acquire systems and operate them in a manner that is typically more efficient than a traditional government acquisition. The best situation is certainly one where the commercial provider, if you will, lives in the house that it builds, where it leverages the same system to support government and non-government needs, and so the totality of its business is based on the success or failure of that system. So the incentives of the commercial provider are aligned with the government.
Thank you, Dr. Scott. Mr. Schingler?
The decadal survey for Earth Science was a great step forward, because it was actually the first time that it was done by the National Academies on Earth Science. And so it really did provide a prioritized list of the data that needed to be collected from a scientific basis. Within that, they had a call for venture class missions, and which, in my opinion, is one of the greater things that we can do in order to lower barrier of entry for new scientists to come in to understand our planet. However, the sensors were not there, the industrial base was not there in order to reach a price point at the time that the National Academy's report was released. Today, it's very different. You could actually see that launch access to space is still a major barrier, and part of NASA Launch Services, together with SMD, is helping to fund $17 million for 3 new commercial nano launch capabilities and access to space. That's a really, really good step forward. But when you combine those things together, you could think about a portfolio of different scientific activities, some of which bring about a rapid amount of capability, taking more risk, but at a much decreased cost. And then with that, that can then help smooth our future critical path into the future. Thanks.
Thank you, Mr. Schingler. Now I'd like to recognize the gentlelady from